Welcome to class. Today, we shall be looking at the usefulness, importance, and application of electrolysis. We started the journey by telling you what electrolytes are, what electrodes are, by discussing with you what is an electrolytic cell. We brought in Faraday's first law and second law after analyzing the electrolysis of some compound in molten and in aqueous solution. Today we are looking at the importance of this chemical reaction, this particular process called electrolysis. The first one I want us to be discussing is the purification of metal. Purification of metal. Purification of metal. Purification of metal. When you have an impure metal, especially that of the copper, let's discuss the purification. Let's not look at the diagram there. That diagram is discussing that of electrolysis of what? Molten sodium chloride. Let's discuss purification of metal. Imagine you are given an impure metal. An impure metal. What do? You want to purify it. Set up your electrolytic cell. How do you do that? Look for a container. Beaker can serve, big one. Get your electrode. The two electrodes. We shall know what the two electrodes, what we are going to use to construct the two electrodes. Let my positive one be here, which is the anode. And let the negative one be here, which is the cathode. Now, which material are we going to use to construct the anode? Bring that impure copper or that impure metal. Make sure you use it to construct the what? Anode. In fact, the anode should be the impure metal. So this anode should be the impure. Let me assume it's copper. This is the impure copper. So here you place that copper that is not pure, that contains impurity, at the anode. What happens at the electrolyte? Take note of this. The electrolyte must be a sort of this element here. But that must be a soluble one. So here can be copper sulfate solution. So after the purification, after the electrolysis, the pure copper will now be deposited at the cathode. So here now is the pure copper. Here now is the pure copper. So you pay attention. That means if the substance to be purified is zinc, probably is impure zinc, it shows that the electrolyte here must be a what? Sort of zinc, soluble one. Could be zinc nitrate, could be zinc sulfate, could be zinc chloride. If it's aluminium that is impure, that means here will be aluminium compound as well. So that is the link. What is to be purified is made the anode. And the pure one, after the process, will be deposited at the cathode where it is collected. How does it work? Now, if you understood what we did before, when the electrode is active, when the electrode here is not graphite, is not carbon, and is not platinum, these three are inert. In as much as what is there is copper, though impure, is an active electrode. The moment current starts passing through, or the moment certain quantity of electricity is passing across, what will happen? This copper, which is impure here, is a solid. Watch it. Copper, which is solid, will dissolve, will enter into a solution and dissolve to produce what now? Copper 2. This is happening at the what? the anode. This is at the anode now. It's no longer just like the one we did before. This is the anode. But before, what happens at the anode is what? Anode does what? Yes, anode loses electron. Here, cathode does what? Gains electron. So here now, the copper, which is impure, is a solid. Once quantity of electricity is passing across, this copper, which is a solid, dissolves into solution to produce this. As it's dissolving, the impurities remain here. The impurities will not follow this copper too. Are you seeing what is happening? So what actually happens now is that this copper 2 now will quickly move to the cathode because cathode is negative. So it's now the cathode, the copper 2 ion is positive. Definitely, it will move to the cathode, which is what? Negative electrode. Entering there, what happens at the cathode? Gain of electron. And then produces what? Neutral copper. This neutral copper now will be the one to deposit here. And is no longer containing impurity. It is now what? Pure. That is how the process takes place. The impure is made the anode, while the pure one comes up after the electrolytic process, where it is deposited at the what? Cathode. The impurities remain inside the electrolytic cell. The moment the metal, which is impure, dissolves, it dissolves to produce ion, metallic ion. The metallic ion does not carry impurity then, move now to the anode where it picks what? Sorry, to the cathode where it picks what? Electron, and then become neutral copper, and then deposited at that particular cathode, being pure. So from impure to pure, this is achieved through electrolysis. You must not forget where you are going to put the impure, or what you are going to construct to be the impure is the anode, solid. But it will dissolve into solution, into the electrolytic cell, where you have a salt, an electrolyte containing that metal. It dissolves. The ion continues. Where the positive ion moves to the cathode, where it picks electron to become a neutral copper, which is now pure. Impurities remain inside the electrolytic cell. That is one. The second application or use is that of coating, electroplating, coating another metal with another. Why? Is to make sure that it brings up its quality, market value, or make it shiny and attractive. When you coat one metal with another metal, it is called electroplating. Probably the one you want to use to coat the other resists corrosion or does not rust. When you do that, the one inside is protected, or the one inside probably its market value will increase. So, let us look at this. Let us assume that we want to coat silver spoon, or ordinary spoon anyway, with silver. Ordinary spoon with silver. Let us coat ordinary spoon with silver. So what are we going to do? Look at the slide. You will notice that my spoon is at the cathode. And my silver, which I want to use to coat the spoon, is placed at the anode, just like what we did here. Exactly what we did here. What's going to happen? Watch. I want to cover a spoon, probably a spoon that is made of aluminum, then want to cover it with a silver metal. What will you do? The same setup. The anode is where you place that substance you want to use to coat the other one. So my saver will be placed here at the anode. The saver will be here. So my anode will be the saver. The anode will be the silver. This is silver, the anode. Why that the spoon that I want to cover, I want to coat with silver, I'm going to place the spoon at the cathode. This is my spoon now. This is my spoon. Then what's going to be my electrolyte? The same thing. My electrolyte will be the salt, soluble salt of silver. Whatever that is here, will have a link to here. So probably we're going to use silver nitrate solution because silver nitrate is a soluble salt. So it's an electrolyte. So what happens? The same process as quantity or current are allowed to pass through this. Once it gets to this electrode where you have silver, the silver, which is solid, will dissolve. This is happening at the what? Anode. Will dissolve into a solution to produce silver ion. To produce what? Silver what? Ion. Now, the silver ion it has produced is positive. So it will definitely go to a negative electrode, which is what? Cathode. So when it gets to the cathode, the silver 1 plus will pick up an electron there and becomes neutral silver. Neutral silver, which is what now? Solid. This one is happening at the cathode. So immediately this silver is produced. As it's being produced, it is actually being deposited on this spoon. It is coating the spoon, it's covering the spoon. Just like the way we just did, where impure copper finally is made to be pure and is deposited here. So this time around, the metal which you want to cover is placed at this position. So after this particular silver dissolves, producing ion, positive, the ion moved here, then collects one electron to become a neutral silver. That silver now continuously covering this particular spoon until everything is done. That is what we have on the slide. Look at it. Electroplating, this is done when a metal is used to coat another to improve on its appearance and to prevent it from rusting. We have it, look at the spoon at the cathode side, which is negative. The spoon is placed there. Then the anode is made the silver. So the moment electrolysis is taking place, the silver solid will dissolve, enter into a solution to produce this silver ion, and quickly move to this cathode where the spoon is, collects one electron to form a neutral silver, and each silver produced as neutral metal is being deposited around this particular metal. Gradually, it will coat and cover the metal. So you can now see that these two applications have a lot to do with what? An active electrode. The moment the anode does not contain platinum, graphite, or carbon, but contains an active electrode like copper, like silver, then note that the electrolyte that will be inside here will be a salt, a soluble salt of whatever that is here. And this time around, the solid from the anode will definitely dissolve into solution to produce ion, which is positive. And that ion that is positive quickly move to the what? Quickly moves to the what? To the cathode, where it picks an electron and becomes a neutral element. That's the second application or the second use. The third is the one we have been dealing with since we started analyzing electrolysis of some compound. That at the end of electrolysis, chemicals are produced. Yes, elements are produced, compounds are produced. That is true. For example, in the electrolysis of, let me look at the next one. Let me look at this one. Let me look at the next one. It's a production or preparation of metals and the compounds. Some elements such as sodium, aluminum, etc. can be prepared using electrode. Yes. For example, in the extraction of aluminum from its ore, from aluminum oxide, when you use electrolysis of molten aluminum oxide, after electrolysis, you get aluminum at the cathode. In the electrolysis of brine, sodium chloride, that is concentrated sodium chloride, after the electrolysis, you get chlorine, which is a substance. So through electrolysis, chemicals are deposited at the anode, chemicals are also deposited at the cathode. And chemicals also remain inside the electrolytic cell. There are other applications, but at your level, these three you must know. Okay? So at this point, I would like us to move to the exam guide and look at some questions and see if we have actually understood this topic. Let's go. The first question here says, okay, let's pick at random. It said, oxidation takes place at the anode during electrolysis. I have said this severally. At the anode is oxidation. Okay, because the anode does that. Is deficient in electrons, is deficient in protons, has excess electrons, has attraction for positive ions. No, is deficient in electrons because electrons are actually moving out from the anode. So if electron is moving out of the anode, that means is deficient in electron. In a simple language, oxidation is defined as loss of electron, and that occurs at the anode. So my correct answer is A. Let's look at another question. Let's pick at random. Look at this question. It said, which of the following statements about the electrolysis of copper 2 sulfate using copper cathode and platinum anode? You see, the anode is inert. Look at it. Is not correct. You say copper is deposited at the cathode. Copper will only be deposited at the cathode if, okay, copper 2 and hydrogen ion, copper 2 is less than the S, I agree. Oxygen is liberated at the anode. Solution, SO42 minus and the OH, yes, I agree, because it's using an inert electrode. It is used for the purification of copper. Purification of copper. Is the anode made of copper? No. So this is wrong. The solution becomes acidic. Copper will leave while the hydrogen ion, copper leaves it, and then OH leaves. So remains H2SO4. Yes, the solution becomes acidic. So D is correct. B is correct. A is correct. The wrong option there is that of the C. It cannot be used for purification of copper because the anode is not made up of copper. Because I told you that the copper salt, which is the electrolyte, must have something to do with what? With the anode. Look at it. If the anode is silver, the electrolyte must be a silver compound. So if the electrolyte is copper sulfate, here is supposed to be what? Copper. But here we are told that the anode is what? Platinum. Can you see that? So the one that is all there is C. We are moving. Let's look at another question, number 15. The product of the electrolysis of dilute sodium chloride, we did this sodium chloride using carbon electrode. You can see the electrode used are inert, so they are not going to have any negative effect on this process. Now we are looking at sodium chloride. Is dilute. So once it's dilute, OH will be discharged at the what? Anode. Finally, what will OH lead to? Formation of oxygen, right? Then at the cathode, between sodium ion and hydrogen ion will be what? Discharged. That means hydrogen gas. So the two gases we are going to get are hydrogen gas and oxygen gas. So let's go to the option. Electrodes are anode. The product of the electrolysis of dilute this using carbon electrodes are chlorine and the sodium. That means anode chlorine, no, it's not concentrated. A is off. Oxygen and hydrogen. Oxygen is going to the anode, correct? While hydrogen to the cathode. The correct answer is B. B. We have done this. In fact, this is one of the examples we use today. Yeah. So let's pick another question. Let's look at that of the number 30. The common feature of reactions at the anode is that A, electrons are consumed. No, electrons are not coming in. Rather, electrons are being removed from there. Oxidation is involved. Yes, there's oxidation reaction. Ions are reduced. No. The electrode dissolves. Electrode dissolves at the anode. It dissolves if the electrolyte has something to do with the anode. Apart from that, it must not dissolve. So the correct answer is oxidation is involved. There is oxidation reaction at the anode. So let's pick another question. Let's go to number 5. Number 5 says, what takes place at the cathode during electrolysis? So if oxidation occurs at the anode, that means reduction will take place at the cathode. Reason, electrolysis is a good example of redox reaction. A reaction where oxidation and reduction are taking place at the same time, simultaneously. So let's go through the option. Option A is anions lose electron at the cathode. Anions lose electron. At the cathode, what happens? There is gain of electrons. So there's nothing like that. B, anions are oxidized. Anions do not even go to the cathode because anions are negative, and the cathode is a negative electrode. So let's go to C. Cations are discharged. Yes, cations will go there, pick 2 electrons, and be discharged. Say cations are oxidized. No, cations will pick 2 electrons to become neutral copper. So moving from Cu2 plus to neutral, that is reduced, not oxidized. So the correct answer there is cations are discharged. Cations are discharged. Cations are positive, moving to the negative electrode. That is the correct answer. That is C. Let's go to another question. Let's go to number 34. Determine the amount of electrons needed to deposit 6.5 grams of copper during electrolysis of what? Copper 2 tetraoxosulfate 6. In brackets, mass of copper is 64. So this is very simple. What do you do? I told you that 1 mole of the element is 64. So we are looking at the amount of electrons. Ordinarily, we have 2 copper, 2 ion plus 2 electrons to give me what? Neutral copper, which is 64. So here we are looking at 2 electrons giving me 64. So how many electrons should give me 6.4? That is the question. So what do you do? X is equal to what? 2 times 6.4 divided by 64. 6.4 divided by 64 is 0.1. So 0.1 times 2 should give you 0.1 times 2. 0.1 times 2 should give you 0.2. So look at the answer. Any 0.2 there? Yes, the answer is what? B. You can see the calculation is coming out. You know, if actually understood those ones we did, the ones here are very simple. So let's go. Number 28. The equation for the reaction at the anode during the electrolysis of concentrated sodium chloride. We use this as an example today. Once the electrolyte is concentrated, the OH will not be discharged coming from water, rather the other anion. So in as much as it's dealing with the brine, which is concentrated sodium chloride, chloride ion will be the one to move to the anode where it loses electron to become a neutral chlorine atom. So the A is the correct answer. Cl minus will give you neutral chlorine plus 2 electrons. It becomes 2 electrons because the atom of chlorine there must not be monatomic, but rather diatomic. So in order to balance such equation, 2 moles are given to the chloride ion at the left-hand side, and finally 2 electrons balance the equation. So the correct answer here is this. that is happening. Yes, reaction at the anode. Reaction at the anode. Finally, let's pick one more. Number 16, we have what product is formed at the cathode during the electrolysis of concentrated sodium chloride. The same question appearing again. So let's look at another one. Okay, what happens at the cathode? Cathode is negative. So positive will go there. Positive will go there. Though it's concentrated, but does not affect the positive ion. So hydrogen ions still move there because it's below in the electrochemical cell as being less reactive than sodium. So hydrogen gas is there. So the answer is B. Okay, forgive me. Let me take one more. Number 3, this is calculation. We are going to round up with this. What mass of copper will be formed when a current of 10.0 ampere is passed through a solution of copper 2 tetraoxide 6 for 1 hour? So it involves copper. I'm still using the equation here. So I still have 2 Faraday here giving me 1 mole of copper. And 1 mole of copper is 64 grams. Therefore, I'm going to get another quantity of electricity here, which is not given. Instead, current and the time is given. The time is 1 hour. 1 hour is 60 minutes. So I'm going to convert the 60 minutes to seconds. So I will be having 60 times 60. That gives me 360. So the time is 3,600 seconds. That will be multiplied by the current. What is the current in the equation? 10 ampere. So I will be having 3,600 seconds times 3,600 times the 10 ampere. So that gives me 36,000 quantity of electricity. That is coulombs of electricity. So meaning that I'll be having 36,000 coulombs of electricity will give me dash mass. By the time I make S subject to the formula, I have S equals to 64 times 36,000 all divided by 2 Faraday. 2 is here. What is Faraday? It's constant, 96500. That is 96,500 coulombs. By the time we solve this, we have 36,000 times 64 grams. That gives us 2304000. If you divide it by 19300, which is 2 times 96500, you are going to arrive at, divided by 19300, we have 1.9. So the correct answer there is that of, okay, let's look at it very well. We have that of the, let's look at 2 times 96500. Okay, that gives me 193,000. Sorry, 193,000. So let's now divide the answer with this. So the final answer will give me 2304000 divided by 193,000. The answer is 11.9. Here we have 11.8, approximately 11.9. Maybe they stopped at 1 decimal point. So the answer is B. So with this, you can see the topic has been well taught and well delivered. So keep making use of the exam guide and explore more, get more questions and solve, and the success will be achieved. Thank you till we meet next time. Bye-bye.